Assalamu alaikum wa rahmatullah. Welcome everyone to Quality Control. Today we will have a new chapter, chapter 15 in our textbook. It is for the acceptance sampling and lot sampling acceptable problems. We will split this chapter into two recorded sessions. First, we will talk about the theoretical part, and then we will demonstrate some practical part and how we elaborate figures and how we can construct those figures on the Minitab. The lot acceptance or sampling acceptance, it is important in productions and factories, and it is commonly be done for the process, whether before you start your process or for the output of your process. Imagine if you are working in a company that produce juice, for example. So the material that will be for the intake, for example, they will use some fruits. Those fruits, they need to be examined before, as well as your juice product, then it has to be examined. So the acceptance sampling is inspection. It is an inspection process for the batch. The batch means the group of material that you are entering to your process to produce your lot. For example, we can refer to a student batch for those students who are entered the university on 41, starting with their student ID, starting with 41. This is a batch. Another batch could be the students with starting ID number 39. So those are different batch. That's mean a group of a population in your process. So it's an inspection for this batch items before or after. So you either do it before or after or both to judge the conformance to the predetermined standards. Now we have to distinguish between the sample in the control charts and the lot sampling acceptance. There is a difference between those two. The sample size in the control chart is to inspect or predict the quality level. Here is to examine the material or the items whether are meeting your standards or your specifications. If you recall, we have talked earlier about the difference between the control limit and the specification limits. It doesn't mean that if the process is having some items or sample size, there are some points are out of control, they are out of the specification. Remember that the specification, it is wider than the control limits. Here, we talk about the samples that you examine for the specifications, not for predicting the quality or monitoring the quality level of your process. Okay, here even we are talking about some items, it could be before you start your process. Means that raw material that you have no control on, that is you are receiving from a producer to process it and produce your own products. Therefore, the sampling plan also has some terminology similar to the sample size and the number of samples we have used in the control charts. The sampling plans can be in one of those three different forms, either a single sampling or double sampling or multiple sampling. The sampling is containing of 3 elements. Every one of those 3 methods, any one of those, it has to contain all of these 3 terminologies. The lot size mean the whole population or the whole batch. The sample size is the number of items you are going to examine out of the batch. The number of samples, how many of those are you going to do? For example, 1 samples or 2 samples or 3 samples. The sample size is for each sample how many items you are going to collect out of the population. So each of the methods or each of the plans, whether it's single or double or multiple, it will contain these information. The lot size is usually constant for all these 3 because regardless what are you going to select in terms of the plan, the lot size will not be different. The difference comes here, where is the sample size, how many items you will select for every sample, and how many samples you are going to have. You can have 1 sample, and each sample has 5 items, so the sample size will be 5, and the number of sample will be 1. You can have 3 samples, and each sample has 5 items, so we will have a total of 15, 5 for every sample. And the sampling plan, it will be based on accept and reject criteria. And this is a major difference between the control chart. The control chart, you are monitoring a process, you are monitoring an output also of the process, but you are not monitoring them based on the accept or reject. You are monitoring the variation. You are monitoring the variation and the quality level. Even if you have a points out of control, remember, doesn't mean that it is exceeding the specifications. That is the difference between the lot sampling or the lot acceptance compared to the control charts. Sample size. A single plan is when we have a sample of n items, small n, and the lot size refer to it as capital N. So here is the lot, referring to it as N capital. For example, the number of students accepted in the IE program for the year 2020 was, let's say, 80 students. So the lot here is 80 students. Or also we can refer to the students who are accepted in the industrial program or industrial engineering program since the beginning of the program. So that will refer to the capital N. The sample is the small n, is how many students I will select in my study or in my examination out of this slot that I just defined, whether the number of students that accepted in the last year. So I will select, let's say, 5 students. So the sample will be 1 and the sample size is 5. I can have multiple samples, and that will be in the sample number of samples will be 5 and the sample size will be 5. I can change any of the sample size or the number of sample based on the plan. But now we are just taking a single sampling plan, only single. So it will be 1 sample out of the lot. The lot will be capital N and the sample will be small n. The number of defectives exceed the specified rejection number. We call that as the C or the cutoff point. That's me. I have selected 5 items in my sample. The cutoff point, if I have 3 rejected items, that means I will reject this lot. I will reject the sample and I will reject the lot. That means if I have only 2 defective, I will accept the lot and the sample. If I have 3, that means I will reject the sample and I will reject the lot. You define the cutoff point. The sample, it is defined based on your plan, as well as the cutoff point. For example, the sample, it could be, instead of 5, it could be 10 students or 10 items. And the cutoff at that time is 5. So the 5 will be the rejection or the cutoff point. If we have 4 rejected, still I'm going to accept the lot and the sample. If I have 5 or more, that means I will reject the sample and the lot. This is, they call it the single sampling plan. The cutoff and the sample size, it is designed based on the consumer who's going to consume the material, or he's going to use the material to produce products. The double sampling plan, I have multiple samples with the same concept. I have a lot or batch, and then I have the first sample that I will examine. I will examine it for the cutoff point that I have defined. The cutoff is how many defective point is acceptable, and the cutoff, they refer it as the cutoff limits or the cutoff lower and the cutoff upper. If it is exceeding the upper cutoff, as we said in the example, let's say 3 defective out of 5 in the sample size, that means it is rejected. So the cutoff upper, it will be 3. And the lower, it can be 0, or it can be, you don't have to define it, because usually they go with the upper limit in this case. But what does it mean here? If the first sample has 3 defective, or let's say 2 defective out of the 5, then it is acceptable, right? Because we said the cutoff point is 3 out of 5. But this is double sampling. That means we have not completed yet the sampling plan. We have to look for the second sample and collect all the defective. So you compare the number of defective found in the first random sample to the cutoff points or the cutoff limits and make the appropriate decision. If it has 3 out of 5, that means it is going to be rejected. You don't have to continue. But let's say you have 1 or 2, you still within the cutoff range. You haven't exceeded the limit. But since it is double sampling plan, you will take another sample. So you take the first sample, you have, let's say, 1 rejected point out of the 5. You still accept that sample. You take the second sample and you do the same. Then you add the number of defective based on the first sample and the second sample, and you add them together. You get the total number of the defective in both lots and make the appropriate decision. Okay, you collect the number of defective in the both samples, and then you make the decision. So if you have, let's say, 1 here and 2 there in the second sample, then you reject the lot. If you have 1 here and 1 here, then you still below the cutoff point, so you can accept the lot. If you have multiple sampling, you extend the same concept of the double sampling. You will take a third one, you will do the same, you examine it, you add all the defective, and then you compare to the cutoff point, whether you accept or you reject. That was just a simple verbal example, but the number of the samples and the number of defectives, those are designed based on the consumer, and it has to be agreed also between the consumer and the producer who's going to produce the material, or the consumer who's going to use this material in the production. And that is also based on the specification. For example, let's say you are using, let's refer to the juice example. The fruits that you are using, it has to be in a certain level of texture or sweetness level. They have to be, for example, tender or hard, depends on your specification. So those, it has to be specified, and then you can say this is acceptable or reject. Again, for the material, like raw material, like steel, you can refer to the steel as there is a code for the steel strength or the quality of the steel. So it can be examined based on the strength, based on the durability of the material. All these, it has to be identified earlier and specified before you go and say reject or accept. I can give you an example. When you go to the farm market and you select your vegetables, you use the same concept. You go and do random or visual or sensing check to say this is acceptable vegetable or acceptable fruit. Also, if you go to the fish market, you do sometimes some checks for the eye clearance of the fish, or the redness or the blood in the breathing system for the fish to check how it is fresh. Sometimes people go and press on the fish and see how it is hard or it is soft. We can refer to same kind of checking or examining, but it will be in a production level, and those specifications are based on the consumer who's going to put it, whether to accept this material or no, as well as for the items that produced. So what they do, this is the steps for the sampling or accepting the sampling. We can zoom in and follow the steps. The lot received from the supplier, you have a supplier who give you the material, then you do random sample. You can use a single sample plan or double sample plan or multiple sample plan to select those material, because you cannot examine all of the material. Sometimes there are automated inspection for all the material intake, but that will be usually costly to do that. Usually random samples will be enough to identify the level of acceptance for the material. So you do the sampling plan or the random sample. The items will be inspected and analyzed, and then the results will be whether to be accept or reject. If you reject it, then you decide to return it to the supplier. If you accept it, then you take it to the inventory or your production. And a question here, how could we identify the number of sample needed? The sample needed, it can be defined based on you as a factory, based on what is the cost that going to be spent, because the testing itself, it is going to be a little costly. So there is no specific number, but we will see how there is a ratio or a relation between how much of defective you have compared to the percentage of acceptance. So that will give you, if you have how many defective you have found in the samples, you can refer to whether the percentage of acceptance to this lot or you don't accept it. But the sample size, it will be based on, as we said, it is random here. So there is no rules for it has to be 4 or 5 or 6 or specified numbers. You specify them, and usually that will be based on the type of testing you are doing, because some testings can be done visually, or some testing needs some equipment to do that testing. For example, if we have like stones like diamonds, it cannot be just examined by looking at them. It has to be under a specific machine to examine them. Also, some materials need to be tested maybe under specific equipments to test their solid or durability, or so there is no specific number for the samples. It will be designed or set by the consumer who will set the number of samples based on the cost of that samples. Maybe you have seen some cars, they go to safety tests and they do a destructive test. And that destructive test means they put that car on speed to test their safety when there is an accident. Those tests has to be done to get the approved by the national or the international safety agencies, and these type of tests are costing. So a number of tests or number of cars to be done in this test is different than when we talked about example of vegetables and fruits. The cost here is different than there. That's why it is usually based on the consumer who's going to do this test. He set the number of the samples. The acceptance of the sampling, we have to clarify some points, and those points are very important here, and I will highlight them here, if you may. The sampling here is not to estimate the lot quality. The lot quality is different than the acceptance lot. The quality, when we talk about the production or the process, we always refer to the variation or the variability within the control limits. Here we talk about specifications. Doesn't mean a specification for the material that used for a Chinese car is when we compare it to European car or a Japanese or another cars makers, that doesn't mean they are not in a good quality, but the specifications are different. For example, a car cannot be produced globally without doing certain tests to check their safety, okay? That type of test is to make sure that is acceptable to be used in the roads and traffics, in the highways or in the roads. As you know, some cars are not designed for roads. They are designed only for racing. They cannot be used in streets. So here we are talking about specifications. We are not talking about the quality. So the acceptance and rejection is based on the specification, not based on the quality. The material used for that Chinese car, and with all respect, I'm just giving examples to make things are more clearer. The specification were accepted in this Chinese car. Also, there is another specification were acceptance in that European car. It could be if those material used in the Chinese car went to the European manufacturer, it will be rejected, but doesn't mean they are not good quality. They are acceptable quality for those other manufacturers. So here we are not measuring the quality, we are measuring the specification. Okay, so to identify the difference, the sampling here or the lot sample to measure the specification. The quality, it is measured by different things or different tools and different aspects. The variability, also when we talk about meeting the standards in the, or meeting the specifications in the quality, we don't use the accept or reject for the sample size. It is other tool to investigate what is the customer's requirements, and then you design your product or your material that it will be used to meet the specification. So we look for the process from the beginning where the raw material is being used. Is it going to be meeting the specification or no? But here we are talking about acceptable and rejected items that is produced or that is going to be used in the manufacturing by another supplier. We cannot go and inspect all their items, but we can do acceptable and rejected random samples to say it is meeting our specification or no. And if it is rejected by us, it could be accepted by others, and that is normal. And we can see there are different items. All of them are sold by different stores, and they could be different in the quality level. Depend on the consumer specification, he will go and buy them. Even for the simple examples, like if you go to the hand soap, you go to markets that they sell some high and fancy brands that is maybe going to be rejected by some consumers, and other consumers, they cannot accept below than that hand soap compared to other brands that it could be maybe cheaper. So here we are not measuring or estimating the lot quality. We are just accepting and rejecting based on the specifications that we set as a consumer. It is not a direct form for the quality control. As we say, it is not for the control chart. The control chart is for the variability. And the last thing is, it is a process conforms to the requirements. You want to make sure the output or the material you are using is conforming to your specification or your requirement. The advantage of the sampling, it is economy, because you cannot examine all the lot, especially when we talk about the huge factories that use a huge amount of raw material that they cannot use or examine all this material, but they do random check for different samples and make sure they are meeting the specification. We can refer to an example that these days also we are facing. For the vaccine that is being approved here in our country, one of the steps that is being done, a team went to the factory itself and take samples and test those samples, but doesn't mean they are testing every product that come out of that factory. So this is how the acceptable and rejectable random samples will be done. It is less handling damage, as we said, for the example of the destructive cars that they use it to crash the car and make sure and examine the safety. it is going to be less when you do sample than comparing to all the lots to do this test. Fewer inspectors, upgrading of the inspection job, and applicability, as we said, for the destructive testing, entire lot rejection. It could be even easier for the producer or the one who is going to use that material to rework it, or maybe find another consumer who can use it with the specification he has. The disadvantage is it has to be disadvantage because you are not testing every item. Risk of accepting bad lots and rejecting good lots because the sample does not reflect the whole population. There is always a correlation between them, but doesn't mean it is 100% accurate. Added planning and documentation, one of the disadvantages. That's mean there is extra paperwork has to be done. Sample provide less information definitely than the 100% inspection. Depend on the critical of the factory that what he's producing. This is also varying in terms of the samples. If you go to airline industry, it is different than when you go to car industry. The level of testing the material and inspecting, it is very different than car or let's say motorcycle in factories, because you are there need to make sure at the end the system you have for the airline or the airplane, there is no chance to have any chance of 0.01 error. So you are working on really high standards. There is no acceptable for defects items. When you go to food industry, sometimes they use some automative machine, give an inspection for the raw material automatically without the need for the human, and also they have some functions that can eliminate the raw material that is defective without need of a human interaction. Therefore, this process of the inspecting, it varies between manufacturer to other based on their needs, based on their nature of their process. The situations where you accept sampling and it is useful, it is extended to the advantage part of the sampling. When testing is destructive, that's mean you have to do destructive, so you don't take the whole lot, you do some sampling because that it will be more economical. The cost of 100% inspection is very high and extremely high. Then you do the sampling. Otherwise, as I said, there are some options where all the lot can be tested without that much of cost. Then it is definitely better to do it than the sampling. When the 100% inspection is not technological, this is the referring to the example I was just explaining. In some food industries, I really recommend you watch some of the making food programs that is under the National Geographic Channel. They are very informative and educated videos, shows how factories work. You are an industrial engineer, can be inspired from those videos how the future of the manufacturing will be. It shows you how there is no limits in the designs for equipments to do jobs for humans that maybe consume from you days to do their job. I've seen many of them that how they test vegetables or fruits or raw material automatically without need to any human, so you can have all the lot be inspected before it is go to the production. I have seen one of the capstone project done at the College of Engineering here in Taiba, and it was about the size of the dates, tamar. Usually the first or the premium sold are in a different price, and how you select sometimes depend on the type of dates you are using. One of the criteria is the size of that dates. So they have designed a tray that all the lot goes on, and only the dates, it will sort the dates based on the size. So you will have the premium sorted automatically and went to conveyor, and then the medium quality or the medium size dates will go to another conveyor, and then the last size. So they have categorized it in 3 different sizes: large, medium, small, and they put dimensions for those different sizes, and then they did holes that can carry each size separately, and then it will filter them or sort them and put them in different conveyor. For example, this is very simple. I'm talking about something that is even not technological. It is more of mechanical and engineering concept. But here in number 3, if the inspection in using such concept is not applicable, then you do the sampling. When there are many items to be inspected, obviously, and the inspection error rate is sufficiently high that 100%, the inspection may cause a higher percentage of defective, and to pass the to pass it on to your product. So if you have inspected items, and those inspected items will affect your production very high, if it's been accepted and they are defective, then you use the sampling. The supplier has an excellent quality history. So you are using some material from well-known names, and going to some countries that produce, let's say, the coffee beans, and they are well known, you know the market, you have dealt with them for a long time. So that will cost you a lot to do the whole inspection for the whole lot. It will be using the acceptance lot or sampling acceptance. It will be applicable in that case. So the last one will be when there are potentially serious product liability risk, and the supplier's process is satisfactory, and the program continuously monitoring the product. So if there is a risk or high risk in accepting, like when we talked about the, some industries, and the supplier process is enough to do the inspection, so they have done part of the job for you, and you can just rely on the monitoring for your production process, and you can do sampling for the raw material. These are situations or scenarios when you can use it, but as we said, especially in number 3, in nowadays there are several tools and several equipments and technological ways that they can do the inspection for the 100% of the lots, and these the cases where you do the sampling size. Today also we will talk about some terms. Those terms are very also important, and we will explain them in detail or in further explanation in the next session. But today we will just go over the definition and know them and know those terminologies that we are going to see them in the lot sampling or lot acceptance. The acceptance quality level, which is the AQL, and this is referring to the percentage of the defect that you are willing to accept. For example, you are going to accept a percentage of 5% of defective in the sample, then this will be the AQL. If it is exceeding the 5%, then that will be rejected for the sample. And if it is a single sampling plan, it will be as well for the lot. The rejectable quality level, which is the RQL, and it is the opposite of the AQL. It is the maximum defect rate is acceptable. So it is the maximum of defects you can accept by the customers or ship to the customers. So those, we can say, both are two sides of the same coin. They are the same meaning. The load tolerance percent defective, or the LTBD, it is derived from the RQL, and it is the defect rate that will be rejected 90% of the time. And it is generally, we can say that the percent of defect that the plan will reject 90% of the time. So if we say the percent is 5%, so 90% of the time you will reject those 5 defect or 5 percentage. So it is the defect rate that will be rejected most of the time, and therefore they have converted to an a probability variable, which is the beta, and studies says 90% or the 0.1, which is the 10%, is the defective or the lot. If it is exceeding that limit of the LTBD, that it will be accepted. And the consumer here in this case, why we refer to it as a consumer risk? Because the consumer, he suffers if you have a lot and is good, and it is being unexpected or unaccepted, and that lot has a defective. So the lot, let's say, has a 10 defective, and you accepted that lot, it will be at the consumer risk. Why? Because he's going to use this raw material and it has more defective than he accepts. So we refer to the consumer risk as the probability of the lot that contain defective exceeding his limits or exceeding his specification. The lot has 100 items, and the LTDB, let's say it is 5%. The probability of a lot contained defective that is 5% to be accepted considered to be the beta, and that's why it considered to be a very small is 10%. So you don't want to exceed 10% of the time to accept a lot that has more than the defect rate that you set from the beginning. On the other hand, the producer risk, his risk is what? You reject a lot that has acceptable items. Why? Because you do the samples in a way that shows high rejected point, and then you reject the whole lot, and there is acceptable quality level. So we refer to the producer risk as an alpha, is the probability that a lot, the lot is the whole patch, contain acceptable quality level, but this will be rejected. So we consider that as the consumer or the producer risk, and it is usually set as a 0.05, which is 5%, or a 95 alpha, 95 probability which is referred to the P equal 1 minus alpha, and the alpha, if it is said to be 95, so the probability will be 5%. So you don't want to exceed 0.05 of the risk of rejecting a lot that has acceptable quality level. And we talk when we talk about the quality level here, we talk about the specified standard. We are not talking about the variability that we have covered in the control charts. We will show them later in the charts how those values can be interpreted. The main chart that we are going to use in this chapter is called the operating characteristic curve, or the OC or the OCC. The operating chart or the operating curve, it shows the relation between the number or the percentage of defective in the lot and the probability of acceptance. Here it will help you to see where you can accept a lot and where you can reject. If you have set the percentage of the defective to be, let's say, under a certain number out of the sample, then that number will be converted into a percentage. This percentage will show the relation of the probability of acceptance that is set by the consumer, and then you can draw this curve, and this curve will show the points. For example, here, if there is a 3% of defective, then the probability of accepting this lot, it will be a 90%. And the probability of rejecting this lot is a 10%. Where if you have 20% of defective found in the lot, that means the probability of accepting it will be 5%, and the probability of rejecting will be 95. We will see how we can draw these charts and curves in the second part of this recorded session. The last thing, there is an example, will be also covered in the coming recorded session. The last part that we will cover is the formula for the average outgoing quality. The average of the inspected lots is can be calculated using the formula of the probability of accepting lot that we have seen it in the curve or the operating curve, times the fraction of defectives or the probability of defectives, times the lot size minus the sample size divided over the lot size again. We will see an example how these can be calculated and demonstrated in the curve, and talk about the terms in more explanation in the second part. Today, our goal was to show what is the importance of the sampling, and when we use it, what are the situation where the sample can be used, and how the terminologies or the inferences about the sampling problem is different than the quality estimation and the quality inspection and the control charts and the quality control. What are the basic steps for accepting? What are the methods or the plans for doing sampling? What does it mean, the cutoff point? What does it mean accept or reject, when we accept and reject in the single plan, multiple plan, and double plan, as well as those definition of the terminologies. And in the second part, we will go in more practical. That's all for today, and we will have now the time for the questions and doing the attendance.